In Unit 5 of Math 120, we begin to look at statistics. We are going to start with some definitions. Numerical information is called data. Statistics is a method for collecting, organizing, analyzing, and interpreting data, as well as drawing conclusions based on the data. Descriptive statistics, which we will focus on, is concerned with collecting, organizing, summarizing, and presenting data. Inferential statistics has to do with making generalizations about and drawing conclusions from the data collected. A population is the set containing all the people or objects whose properties are to be described and analyzed by the data collector. A sample is a subset or subgroup of the population. In order to use a small sample to make generalizations about a large population, one must guarantee that every member of the population has an equal chance to be selected for the sample. We look at two things to decide whether something is a good sample. We want it to be both random and representative. A random sample is a sample obtained in such a way that every element in the population has an equal chance of being selected for the sample. A representative sample is a sample that exhibits characteristics typical of those possessed by the target population. We are going to look at an example to determine the best way to obtain a sample. The government of a large city needs to determine whether the residents will support the construction of a new jail. The government decides to conduct a survey of a sample of the city's residents. Which one of the following procedures would be the most appropriate for obtaining a sample of the city's residents? We have four options. Survey a random sample of the employees and inmates at the old jail. Survey every fifth person who walks into City Hall on a given day. Survey a random sample of persons within each geographic region of the city. Survey the first 200 people listed in the city's telephone directory. Let's go through them in order. Remember, we want the survey to be random and representative to get a good sample. So this first one has random right in there. Survey a random sample of the employees and inmates at the old jail. However, it is not representative because we're only looking at employees and inmates at the old jail. We want this to represent all of the residents. So that one does not work. We don't want to choose option A. Option B says survey every fifth person who walks into City Hall on a given day. So it could be kind of random with that fifth person. However, this one is also not representative. Not everyone goes to City Hall every day, so it might not be all of the city's residents. C says survey a random sample, so that's good, of persons within each geographic region of the city. So that would get people that live in the city. It would get our residents. So it is representative. So far C is the best option, but we should still check D. D says survey the first 200 people listed in the city's telephone directory. So in this case, it is representative. If they're listed in the city's telephone directory, they're residents of the city. But for the first 200 people, it's not random. Right? People that have a last name that start with A are much more likely to be surveyed than people with a last name that start with C or Z. Our final answer then is C. That is our sample that is both random and representative. Once we have our data, we want to organize it. And usually we organize it into graphs. So after the data have been collected from a sample population, the next task facing the statistician is to present the data in a condensed and manageable form. So we're going to explore organizing data using many methods. In this video, we're just going to look at the frequency distribution. A random sample of 15 male college students is selected. Each student is asked his height to the nearest inch. And the heights are as follows. We have a list of different numbers that seem reasonable for heights in inches. We are going to construct a frequency distribution and a grouped frequency distribution for the data. When we're trying to make a frequency distribution, we always need at least two columns. One for a label of whatever was actually measured, in this case height, and one for how frequent something occurs. If we're making it from a list of data, we sometimes also put a column in the middle called tally to help us figure out what the frequency should be. When we do this, we need to look for the smallest height and the largest height. So if I scan the data, the smallest height looks to be 66 inches, and the largest height seems to be 75. What I'm going to do in my height column is start at 66 and just go up 66, 67, 68, 69, all the way up to 75, that highest height. I'm going to extend my lines for the table. Now, what I'm going to do is go through the data in order, the order that they give it to me, and put a tally mark next to the height. 72, I put a tally mark next to 72. 70, I put a tally mark next to 70. And as I look at each number, I cross it out. That helps me in case I get interrupted or I lose my train of thought. I can see what numbers I've already placed without having to completely start over. So I have my first 71, my second 71, my third 71. I'm going to keep going. I have 69, 73, 71, 73, 75, 66, 67, and last 75. Once I have these tally marks, I can now list the frequency. 66 occurred once, as did 67, 68, 69, and 70. 71 happened 4 times, 72 happened 2 times, 73 happened 2 times, 74 did not happen at all, and 75 happened 2 times. We can also make what is called a grouped frequency distribution. And in that case, what we do is group 2 or more heights together. So I'll still make my titles. This time I'm only going to have height and frequency because we already did the tally. We already counted everything up. And I need to make sure that when I group the heights together, I have equal size groups. So I could have 66 and 67 as my first group, as long as every height after that, every group has 2 heights, like 68 and 69, 70 and 71. I could not say, oh, I want my first group to be 66 inches to 70 inches, and my next group to be 71 inches to 72 inches. So what I'm going to do, because we have a decent amount of heights, but it's not like it's in the hundreds or 20s, I'm going to make my grouped frequency distribution have the heights of 2 inches together. So my first group will be 66 to 67. My next group will be 68 to 69. Then I'll have 70 to 71, 72 to 73, and 74 to 75. One other thing I want to point out, notice there is no overlap. I go from 67 to 68. We don't want something like to have the first group as 66 to 67 and the next group as 67 to 68, because then I wouldn't know where to put the person that is 67 inches tall. Now I can make the frequencies. I look back at my other frequency distribution. 2 people were 66 or 67 inches tall. 2 people were 68 to 69 inches tall. 5 people were 70 to 71 inches tall. 4 people were 72 to 73 inches tall. And 2 people were 74 to 75 inches tall. That leaves me with my grouped frequency distribution.